Hello and welcome to General Chemistry. Before we get too deep into the material, we need to start with some foundational terms that we all understand to be true. And so that's sort of what this first lesson is really about. So hopefully this is a review for you, but if not, that is totally fine as well. So let's start by just defining what is chemistry. Well, chemistry is the study of matter. And matter is anything that has mass and occupies space. And as you may know, there's several different forms of matter. We have things that are solid. These have fixed shape and volume. Things that are liquid, they take on the shape of their container, but they have a fixed volume. They're not going to expand so much at a given temperature. And then we have gases, and gases will adjust to the volume and shape of the container. There's another form of matter that we may not talk about as much, and that's called plasma. That's a high energy state, and yeah, it's kind of cool because it can take part in your TV in a way. So just so we all are on the same page, I want you to know that mass is not the same thing as weight, even though we may use those terms interchangeably. But weight is actually something that's affected by gravity. So on this planet, we, have a constant gravity, and that's the reason why those two terms can be somewhat interchanged a little bit. Okay, I'm just going to move this up a little bit. So there is something called the law of conservation of matter. This is a law that basically says that the mass of the reactants or the starting materials in a reaction are equal to the mass of the products of a reaction. This is something that we're going to use a lot. In other words, mass is neither created or destroyed. And you see here how I've written this term. The reactants lead to the products. Or I do this little arrow here because what that says is one thing goes to another, and we're going to see lots more reactions like this moving forward. I'm going to move over now to this little side note, talking about the scientific method. I'm sure that you've seen this before, and there's lots of different variations of what this scientific method looks like. But basically, what we start with are observations and questions that you may come to. This is something you do every day. How do I get the best parking spot? What is it that is the best way to tie my shoes? I mean, this is something that you did as a child too. These questions lead you to hypotheses or an hypothesis. And hypotheses usually are like if-then statements. If I do this, then that will happen. If I get there early, then I'm going to get my right parking spot. You then can perform an experiment. You get there early for 5 days. You get there late for 5 days. You get there on time for 5 days. When do you get the best parking spot? That might be your experiment. Your data is then something that's recorded. Usually this is something that's measurable. So things like where my parking spot is, how far it might be from the class, things like that. Observations. Did the color of the parking lot change? Well, in this case, I hope not. But, you may see that in other types of reactions. You then draw a conclusion. Now, here's the thing. Here's the thing that a lot of people get mixed up on. They don't relate it back to the hypothesis. Your conclusion has to be what your actual hypothesis was. If I get there early, then I will get a good parking spot. So you need to conclude, I got there early and I got a good parking spot. Or I got there early and I didn't get a good parking spot. Not if I got stuck in traffic, it messed me up. That is not going to be directly related to the hypothesis. So you have to have some type of conclusion that's directly related to what your hypothesis is. If your conclusion over and over and over and over again comes to the same conclusion, eventually this will turn into a theory, and way in the future, it may be a law. It takes a long time with lots of experiments to make these theories and laws happen. I do want to make sure that we all know this because this is very important. Nothing is ever proven in science. You can only disprove your hypothesis. After a while, we accept some things to be true, but that doesn't mean it's proven. So be careful using that term. That's not something that we should really say as scientists. Okay? So now let's go back over to the types or terms of matter over here. Okay? So the first type of matter is something called a pure substance. This just means there's just one thing there. So one element or one compound is present. An element is something that's found on the periodic table. I love ptable.com. If you haven't checked that out before, check it out. We'll also talk about that later as we go on. And a compound is a combination of elements of defined ratios like H2O. What that means is 2 hydrogen, 1 oxygen. We'll talk about that too. Water is a compound. H2O2 has a different ratio. So in other words, it has 2 hydrogens for every 2 oxygens. And therefore that's a different compound because there's a different ratio. So don't get confused. Don't drink hydrogen peroxide. That's not advisable. But if you drink water, that's probably a good thing for you, right? Okay. So in comparison to a pure substance, there's something called a mixture. Well, a mixture is 2 or more types of substances that can be separated somehow. This may be harder than it actually sounds like, though. We have 2 types of mixtures. There's heterogeneous mixtures. So this is like sand and water. Milk is actually a heterogeneous mixture. It's got lots of water in it. If you let it sit for a long time, you'll see that difference. It may not be the same throughout within a heterogeneous mixture. Homogeneous mixtures, or what we call solutions, appear to have a uniform consistency. In other words, they may look like they're the same thing as water, like salt water. But do you know that brass is actually a homogeneous mixture as well of 2 different metals? So there's lots of different types of mixtures, and they can even be solid. That's kind of neat. Okay, I hope we all know what an atom is, but this is basically the smallest unit of an element that still retains its properties, These guys are so small, you can't even really process how small that is, and we'll talk about that as we move on too. And a molecule is a combination of different atoms. Sometimes we see that as being like O2 or N2 or something like that. And that is a term that you'll often see linked to 2 of the same things, or better yet, the same element combined. Sometimes that's not the case though, so don't worry about that. It can be used interchangeably with the term compound, and is pretty often. Okay, moving onward. There's different types of properties that we can see as well. A physical property is something that does not affect the chemical composition of a substance. So, things like boiling point, melting point, color, density, conductivity, in other words, how easily something conducts electricity. There's also things called physical changes. So these changes occur when substances change their state of matter. So you've got something going from solid to liquid or liquid to gas, and those are physical changes. Those are different from chemical properties and chemical changes. So a chemical property is the ability of a substance to react with another substance or not. So this could be like acids reacting with bases, how easily something combusts or burns, what reaction happens with this guy versus another. And chemical changes are going to produce different chemical compounds or molecules than the reactants you started with. So there's an actual change of the ratios of those elements. Sometimes the lines between chemical and physical changes can be really hard to identify. For example, frying an egg is a chemical change because you're actually changing the chemistry by adding heat to the egg. That's the reason why it's not so bad for you when you do that, okay? And finally, let's talk about extensive versus intensive properties. Extensive properties depend on how much you have. So this is things like volume and mass of something. Versus an intensive property is something that does not really rely on the amount of something that's present. So temperature does not rely on how much something is present. Okay? Check out ptable.com and I'll see you at the next lesson.